Hey y'all, how's it going? Welcome back to another episode of What's in a Game. Today, I want to show you a new hack I found for Pacman. It's really easy to pull off, and you're seeing it here first. Let's get started. So the game actually creates each level from the DNA of the previous one, just as our bodies replicate DNA to create new proteins and cells. If you do a single 360 turn of the joystick before you start a new level, the game actually lets you see this process. Let's take a look. The money you put into the game acts as an initiator protein, activating the origin of replication. A replication bubble opens up, which has two replication forks. The characters work at both to make each level. For now, though, let's zoom in on one fork and see what's going on. Pacman acts as helicase, opening and unwinding DNA. Let's zoom in even more. Nucleosides on each strand of DNA are connected by phosphodiester bonds, circled in yellow. Pacman eats through hydrogen bonds to separate and unwind the strands of DNA. The power pellets act as single-stranded binding proteins, stabilizing the single DNA strands and preventing them from becoming double-stranded hairpins. Blinky, the red ghost, acts as gyrase to relieve supercoiling ahead of the replication fork and reduce torsional stress in the DNA strands. Inky, the cyan ghost, acts as primase, creating short RNA primers. They are usually 10 to 12 nucleotides long and have a free 3' alcohol so that the synthesis of new DNA can begin. Pacman and Inky work as a unit called the primosome. Pinky the pink ghost acts as DNA polymerase III. He comes in at the free 3' alcohol and begins to synthesize DNA in the 3' direction. Pacman and Blinky continue to unwind the DNA in a process called elongation. Let's fast forward a bit. Here we see that Pinky has continuously replicated DNA on the leading strand and is moving in the same direction as the replication fork. On the lagging strand, Inky continues to lay down RNA primers and Pinky replicates DNA, but the replication fork is moving away from the actual replication. This results in discontinuous replication and creates segments of DNA called Okazaki fragments. Luckily, the game, and our bodies, can make these into continuous DNA. Clyde, the orange ghost, acts as DNA polymerase I, removing the primers laid down by Inky and continuing DNA replication in the 3' direction to fill in the gaps on the lagging strand. Small nicks are left, with only a sugar phosphate bond missing between the new segments of DNA. The cherry bonus from the game acts as ligase, sealing these nicks. Fun fact, the newly created segments of DNA were replicated from 5' to 3'. The strands they were replicated from, however, run from 3' to 5'. This is because double-stranded DNA is anti-parallel. And just like that, you have a new level to play. Thanks for watching.